In this video, we're going to continue our discussion with dividing radicals. Now we're going to talk about rationalizing the denominator when the denominator is a binomial. Now, if you recall, we talked about when we take a minus b and multiply it by a plus b. This is the product of a difference and a sum here, and that's a squared minus b squared. When we multiplied by the conjugate, we got rid of all the radicals. So we're going to use that idea to help us rationalize now. So let's take a look at the first example. Notice you have a binomial in the denominator, square root of 3 minus square root of 2. So now I want to take the conjugate of the denominator. Well, that is the square root of 3 plus the square root of 2. Remember, I can do this because I'm multiplying by 1. And when I multiply by 1, nothing changes. So on the top, it's a monomial times a binomial. So I'm going to distribute. And I'm going to distribute. On the bottom, it's the square root of 3 minus, square root of 3 times the square root of 3, that is 3. And negative square root of 2 times positive square root of 2 is negative 2. So here I've shown the square root of 18 simplifies to 3 times the square root of 2. And the square root of 12 is 2 times the square root of 3 when you pull out all the perfect roots. Okay, so let's put that in. Notice 3 minus 2 is 1. And when you divide by 1, you get just the numerator. Okay, let's take a look at the next example. So again, notice you have two terms in the denominator. So I'm going to multiply by the conjugate. Well, the conjugate here is the square root of 5 minus the square root of 2. So I'm going to multiply the top and the bottom by the denominator's conjugate. In the numerator, it is a binomial times a binomial, so I'm going to FOIL. Square root of 3 times the square root of 5 is the square root of 15. Square root of 3 times the square root of 2, that's negative square root of 6. Square root of 5 times the square root of 5, that is a positive 5. And the square root of 5 times negative square root of 2 is negative square root of 10. All right, on the bottom, the square root of 5 times the square root of 5 is 5. Square root of 2 times negative square root of 2 is negative 2. There are no perfect roots I can pull out of 15, 6, and 10 other than 1. And there are no like radicals, so I'm going to rewrite the numerator over the denominator. Now, if you want, you can separate them like this if you would like. Not required, but I will show this. Both of those answers mean the same thing. One more example to look at. Again, notice the denominator. The denominator has two terms. So I'm going to multiply both the top and the bottom by the conjugate. Okay, so foiling on the top, 3 times the square root of 2 times the square root of 6, that's 3 times the square root of 12. 3 times the square root of 2 times 5 times the square root of 3, that is 15 times the square root of 6. The square root of 6 times the square root of 6 is 6. And the square root of 6 times 5 times the square root of 3 is 5 times the square root of 18. On the bottom, again, because it is the product of a difference and sum, I'm going to take the square root of 6 times the square root of 6, that is 6. 5 times 5, that is 25. And the square root of 3 times the square root of 3 is 3. So on the side here, I've done the square root of 12, pulling out the perfect roots. That ends up being 2 times the square root of 3. Pulling out of the perfect roots of the square root of 18, that's the same thing as 3 times the square root of 2. So when I replace these, I get this. And notice I also did 25 times 3 on the bottom. So with the top, 3 times 2, that's 6, times the square root of 3, plus 15 times the square root of 6, plus 6. 5 times 3 is 15, times the square root of 2. And 6 minus 75, that is negative 69. If you do not like the negative in the denominator, I can rewrite it like this. So either one of these answers would be okay.